Firstly, I want to thank you for the opportunity to speak, and I'm happy to present goal routing as the founder. What goal routing tries to achieve is a revolution in collaborative logistics. Current models are mostly based on a hub-based system like the spoke and hub system, where most deliveries go to a hub, maybe multiple hubs, where most systems use the spoke and hub system, which consolidates deliveries in hubs and later disperses them from a different hub. Alternatively, another typical example is the point-to-point system, more typical in truck logistics for larger loads. But with the current company systems, we have multiple separate systems of networks that don't collaborate and need more resources because they need to take additional detours because they cannot share resources. Now, in such an example, where we have the same origin and same destination from 3 different providers, we might have a provider A that has a hub with a highly utilized link after the second hub, have a provider that is able to offer a direct connection, and one that offers another one over another hub. But if we now have a provider for which the distribution or collection network is failing, so we have a disruption, then we cannot provide services, or provider B is left without the ability to provide logistical services. Now, there are some agreements between singular companies to support each other or have single-time contracts, but not a large solution. If we look at the offerings for parcels, we see a lot of competition in pricing and in time to delivery, but we don't see a lot of diversity. Does every parcel need to be delivered in 1 to 5 business days? Or could we save resources on delivering some in 10, using off-peak logistical capacity? Now, how could we solve that? Our approach uses a transport contract, where each transportation unit has an attached contract that includes the destination, some limitations, like maybe you don't want to route through Saudi Arabia or China, and a compensation function. The compensation function is a time-dependent function depending on the time of delivery. So you can define, in this example, we've got a peak where the delivery would be most helpful, but we see it's not as bad if it's delivered a little later. If we now introduce the cost to delivery, we see that we've got a capitalizable area that we want to take advantage of, and we can better optimize our network. We would like to get it delivered, but okay, that's not helpful. But it can also be later. We don't need to do it as fast as we would normally do with tight constraints and just singular offerings. Now, where do we have another system that uses destination-based routing to solve such problems in a distributed manner? That would be one example would be the internet, which uses a destination-based approach where we have an IP address, and each router advertises how far it is from that particular address or that block of addresses. And then the neighboring routers know, okay, this neighbor is so far away, we can add the cost of our link and then advertise that distance, leading to shortest routes being propagated throughout the network while providing routing services. Now, if it doesn't know where package or data should go, or it's overloaded, it's going to throw it away. So we can't really use that for logistics, but we can adapt it. So this would be an example where we've got one parcel that needs to go from right here to ETH Zurich in Switzerland in 4 days. Now we've got multiple offerings, bids, from different companies at different places. So for one, we've got a direct flight to Berlin, just a commercial flight that is offering some services because not every passenger is carrying luggage, at 17 monetary units. Another operator is offering it through Mumbai because there's more capacity available there, and another one via Paris. This allows us to dynamically look at the usage and use the spontaneously available capacity. For the example, in der Beispielstraße 12 in Berlin, Germany, we've also got the direct flight, which would be cheaper because we don't have to pay for further transportation, which would be organized by the provider that is offering the Berlin hub, because that provider is then taking over the transportation contract and is responsible for further transport. But it is a lot more expensive than going to Mumbai or Mangalore to be loaded onto a ship, because we've got a ship that has some not completely filled containers that we can use to put parcels in and deliver our parcels more cost effective, utilizing more of the resources that we have available without investing any additional funds. Now, going back to this example with the failed links, the middle provider can just advertise its direct services, and this allows us to, in this example, go from the B start point to the C provider, use the distribution network, go via the direct connection, and then use the direct network of A, while each operator is economically incentivized to participate, as they are using unused capacity and using revenue that would otherwise not be available to them. Now, this is also a great advantage on the topic of resilience. If we're taking the example of a single warehouse, we've got incoming traffic that could be disrupted by previous stops, link failures, failing vehicles, or just schedule constraints. The truck driver just has to legally take a break. That means in the warehouse, we've got an undersupply of supplied goods and an oversupply of outgoing capacity. The other direction, if we've got a disruption in outgoing traffic, through pretty much the same reasons, we've got an oversupply of goods and an undersupply of logistical capacity. Now, if this is in a network and we can propagate the distances and costs and how the capacity changes, we can change the routing via different warehouses and prioritize with the compensation function. We can use the data that we retain for each transportation unit to more efficiently adapt routing. Now, summarized, the advantages are improved sustainability, improved efficiency, increased collaboration between operators, reduced overhead in planning as it is managed digitally, strengthened resilience, increased capacity, and the best thing of all, we don't even need buy-in from any large provider. So, this is Goal Routing, standing for Globally Organizing Available Logistics, and I thank you for the opportunity to present.